Well, hello again everybody, and today's another episode of my Board Racer series of videos where I'm going to be taking a look at doing some more machining for my friend Andy, who's making a Board Racer style tribute bike. So what we've got to do today is, I've already done quite a lot of the machining on this, and I didn't show it you because you've seen it all before, but we've got this cog here which I had to basically machine out. It had a spline shaft on it, and I've machined the splines off it so we could actually get it over this bit of round bar. And one thing I should say about this wheel is it's absolutely really hard. It's harder than a coffin nail. It's some form of hardened steel, and you can tell as much as anything by the sound. I mean, this is obviously a file which is very hard material, and the files, it's just bouncing off it. It's not taking a cut. I mean, it might be making a bit of a mark. It's basically just scratching off the corrosion, but there's no shavings coming off. So this stuff is seriously hard material. So I think I said I made this flange previously. It actually goes that way around. And I've machined this on the lathe, and the idea is that this fits over there like that. Well, what I actually want to do is, these have got threaded holes in at the moment, and I actually want to drill them out because I won't be able to tap this material. It's too hard. I suppose one thing I could do is I could heat it up somehow and then try and anneal it, but yeah, all that sounds a bit iffy as well. So what I basically want to do is, rather than just having 2 holes in here, I actually want to drill 4 holes, but make drill these out just to be clearance. I think off the top of my head, I'll have to double check it. I think these are M6 screws, but what I want to do is I want to drill and tap this, and that's why you see I've cut this groove into it here. That's because what I want to do is I want to have to drill through this, and I want the drill to be able to come through this side into fresh air, and yeah, basically that's the way I've designed it to work. So we also need to drill 4 holes in this, which won't be any difficulty because it's just mild steel. So I think the first job to do today is to kind of work out what the centres are for these holes, because as I say, I'm going to have to replicate this hole pattern. I'm going to have to drill 4 holes in this. I'm going to have to drill and tap 4 holes in this. So yeah, we need to find out what those holes are first. So let's crack on with that. I guess there's a few ways that we could measure this, but what I think I'm going to try and do is I'm going to just put these long studs through, because I can measure the shanks of the bolt. I can actually get something positive on there. I think I'll just tighten a bit of a lock nut behind here just to stop everything floating around, because a little bit of wibble wobble in those, not a lot, but a little bit. I don't know if the photography in here is looking any brighter, but just yesterday, Saturday, I installed LED lights in the garage because I had been struggling with some time doing some of the machining, because I guess getting older, my eyesight isn't exactly as good as it was when I was 20, and I just find that I was struggling to see things, and it wasn't really bad, but I just find out that, you know, more light is better than less light. So I've installed these quite high-powered LED tubes, and so far, I mean, this is the first day I've had them switched on in anger, but I'm really enjoying them. Well, that's a bit different. You don't normally go on top. 5.8, 5.85. 5.84, let's just check the other one. 5.85, 5.85. I think we're going to call the diameter of these screws, what do you call that? Is that the shank of the bolt? I think we're going to call that 5.85. I'm going to call it 39.65. So what were our numbers? We had 39.65, and to get the centre we need to take off the diameter of one of our screw shanks, don't we, which was 5.85. 0.85, which is 33.8 millimeters. Hopefully. Yep, so I'm fairly happy that I have just proven what those centres are. So basically what I was trying to say is we want 2 holes here, and we're going to want another 2 holes there and there. Coming through heavy metal. So we've set up our rotary table, and we're going to use that to drill our PCD around this, I guess we call it flange, but can't fit that in here. The jaws won't go out wide enough, so if you've seen me do this before, what we've got to do is take these jaws out, put these in, and I'm hoping that these jaws will actually fit that, fingers crossed. Fingers and thumbs today. That's jaw 1. So jaw 1 has just clicked, so let's go with jaw 1. Yep, so all them are evened up now, so it looks like for some reason this chuck has to go in with jaw 1 first. I think that's different than what the other one. So is this going to tighten up on here now? Fingers crossed. Ah, no it doesn't. Does that mean we'll be able to grab it on that inner one? Yeah, it does. Quick spin on the old wanking handle. Lovely. Well, we're back at the milling machine now, and one of the things that we need to do is, before we carry out our machining operation, before we drill our PCD, our 4 holes on here to match this, what we've got to do is we've actually got to centre this up, and there's a few ways we can do that. In the past you've seen me using these. This is just a piece of metal, it's a piece of aluminium that I've just turned down on the lathe, and I've actually put a little centre drill mark in it, and I think you might call this a toolmaker's button. I think that might be the correct name for it. So, because I guess it's a little bit like a button because it's round and it's got a hole in it. I think that's what they call them in Sheffield anyway. So one of the things that you could do to find the centre of here, because I've got a pointer stuck on here, so what you could do is you can just push that in there a little bit. That's gone in, and because this is symmetrical, you know, it's a round piece of metal, it should line up with the bore in our flange here, and that should be the centre point. So in theory we can I'm just turning the wanking handles there, spin the other wanking handle. Not quite there, are we? Okay, so that's you can see that we've more or less found the centre, and I'm sure that would be good enough for what I'm actually trying to do today. But as everybody knows, more gear is better than less gear. So I've actually bought some more test equipment. I've bought what they call a centering indicator. So let's have a play with that, see if we can get to work. So here's our centering indicator, and I think these are probably made in China like so many things are today, but they're actually supported by a company in the UK, and I've had dealings with this company before and I actually think they're very good. They've actually got a video online showing you how to use this and set it up, and it does come with their own printed leaflet, which is so much better than some of the equipment that you buy from China, etc. Anyway, so this came from machinedros.co.uk, and they are based in Hoddesdon, Herefordshire, EN11 0BZ. As I say, I don't have any affiliation with this company. They haven't given it to me or anything. I've had to buy this. Mind you, if they do want to give me some equipment, I am a bit of a whore and I'm quite happy to accept it. I will do it for money. So there's that. So what that consists of, it consists of basically this gauge here, and this end of it goes in the chuck. I think that piece of plastic is just a packing to stop it bouncing around. And well, I guess the nuts of it is it's got this little lever here, and if I press this little lever, you can see the big dial there sweeping round. So what we actually do is we install this in the machine, and we kind of run the machine slowly, and this lever, this little long arm with its ball on the end, that's going to run round the inside bore of that flange that we put on there. And if it's not dead centred, this arm will be deflected to one side and it will make the needle do that. So basically we put it in the machine, we turn it on at a very low speed, and then we adjust the wanking handles until this needle stops jumping around. Oops. So this is a collet, and it's actually a brand new collet. It's never been used, this one. And the thing about collets, they're designed for holding things, but because most of you are probably used to using a drill chuck, and the thing about a drill chuck, it's kind of designed to fit everything badly, whereas a collet is designed to fit a very specific size and really not very much else. This is brand new, and it's again, these are Chinese manufacture, and they tend not to be bad, but I'm just feeling that this is a little bit sharp. It's just needs a little bit of finishing. So before I actually stuff this into the female part of my milling machine, one thing you don't want to do is you don't want to damage the inside bore of the spindle. So I'm just going to get a hone, a stone, and I'm just going to create a little, soften that edge up a little bit. This is the bit that needs to be held in the machine, and this will go in there. And but it will actually hold it much more accurately than a chuck would have done. A chuck always has a little bit of run out, although you may not see it. You think the drill is running on centre. If you actually put measuring equipment on it, you'll see that the drill is kind of twitching from side to side a little bit. Well, it will wobble about from side to side much less when it's actually held in a collet than it would if we'd just held this in a drill chuck. So let me just go and stone these rough edges off, and then we'll install it, and we'll get the show on the road. This long rod, this is called the drawbar, and this is the thing that you saw me undoing at the top of the milling machine. So what happens is basically the drawbar, it screws down the centre of the spindle of the machine, and it screws into the back of our collet, and then we've got these lock nuts at the back that actually, what they actually do is they pull the collet into the spindle of the milling machine, and because this has got a cone shape, it's like a wedge. As this pulls into a fixed size hole, what it will actually do is it will close up the collet, and it will grip very tightly on our M10 shank of our test instrument. So that's that's what a collet is. I'm just giving you the little bit of knowledge I know. This is a first for me. I've never used collets before, or certainly not this type of collet. They're meant to be incredibly accurate, so you know, here goes for the first time. Looking forward to it. I've just barely knit that up. I'm sure you don't need to do that very tight. Anyway, if it flies out of the machine, I've not done it tight enough. Yeah, I'm playing this a little bit by ear because I've never used one of these before. As I said, I've just watched the YouTube video. So I've purposely twisted one of the wanking handles down here so that it is actually now slightly non-centered, because we centered it previously. So if I turn this now, it's probably easier if I take the machine out of gear. Let's just try and get it between gears. That's between gears now. If I turn, trying to find it. Okay. Hopefully you can see the little finger spinning round the inside of the ball, and because it isn't centered, because it isn't this little rod which is touching the side wall of our flange here, because they're not concentric to one another, it's making this arm move in and out by different amounts. So basically what we're trying to get rid of is, we're trying to get rid of all this deflection that we can see. I think there's another little handle we're meant to install on here to stop it spinning. Let's go and find that. So what I'm going to try and do is I'm going to turn this handle in whilst I'm spinning the spindle, and this is going to move the whole table forward, and in theory we want this needle to stop wagging backwards and forwards, so that's what I'm going to be turning, this handle down here. Looks like I'm a mile out at the moment. Right, okay, that's a little bit better. I'm going to put the machine into low speed. Yeah, that's in low. And because this is, it's got a variable frequency drive on it, I actually can run it very slowly. So you are allowed to run these under power. What I will do is, I think it said put a little bit of lube on there, so we'll do that. Right, low speed selected, let's turn the machine on, hopefully this will work. Oh, it's still a bit fast, let's slow down a bit more. Right, that's as slow as the machine goes. See, the needle's not wagging round as far now, so I think I'm getting closer to it. Okay, so I've adjusted that one. I think maybe it's the y-axis that needs adjusting a bit. Let's try that. That's getting worse, isn't it? Okay, back to the y. Sorry, back to the x. Okay, I'm going to say that that's good enough. That was actually quite fiddly to do, but ultimately quite pleasing. Now we've gone to all that trouble of centering the machine with reference to our internal bore. We'll zero out the DRO. Then, even if we actually move the the handles on the machine, it won't make any difference, because we'll always be able to find the zero just by looking at the DRO. Really is useful, this DRO. I'm using this milling machine an awful lot more than I use the old one, and what it's really come down to is simple things like, actually the machining process isn't that hard, learning to machine things. What's really hard is the measuring equipment and stuff like that. I think that's where the skill is. I mean, they call them machinists, but I suspect that most people that call themselves machinists, I'm not trying to take anything away from them, but one of the main skills about machining is just being able to measure stuff properly, because if you can't measure stuff accurately, how can you machine material off it? Okay, so I've just installed our little tool maker's button into our flange, and in theory, when I just plunge the centre drill into the little hole we've got drilled in the tool maker's button, in theory it should line up. There's a theory. Yep. G10. Well, we worked out the distance between the two holes in this sprocket, and it was 33.8. So what we now we've found the centre of this, we want to move the drill to drill these holes. We need to move it half of 33.8 to find to there. So if we do 33.8 over 2 equals, brain hurts, 16.9. See, basic maths defeats me. So it doesn't really matter which of the axes we move, as long as we move one of them by 16.9. So yep, back on the wanking handle. Come past it, back again. 16.9. This isn't particularly hard material, this. In fact, that's going quite easily. Right, well that was our first hole completed, and yeah, hole number 2 now. So just release the stops on the rotary table, and we're going to turn the handle so we've got 90 degrees. Well, in theory, that's us. We've done our business.